More about table spaces. Like I've said several times, a table space is a logical storage container for those segments. Segments, we know, are those database objects. Table spaces can certainly contain one or more data files. It's not a one-to-one relationship between table spaces and data files. You want to consider as an Oracle administrator where you're placing those data files. That's something I'll show you in a demo in just a minute. You don't operate on the data files directly. Instead, when you're managing data, you do it at the table space level or at the instance level, and it winds up affecting your data files. Okay? Now, something else to consider. A single segment cannot span multiple table spaces. In other words, we can have a table, and that table may grow large enough to where that table segment can't all fit on a single data file within a table space. So in that case, as an administrator, you would hopefully either proactively alert yourself of that problem, or Oracle monitoring tools can let you know that there's a space problem. You can deploy or create an additional data file in that table space, and the segment can grow into that second data file. That's fine. But with Oracle Database, you can't have a single table or segment spanning multiple table spaces. You can do that, but not without partitioning or actually splitting the segment into sections, okay? Now, as far as what table spaces are required, the two that are absolutely mandatory in any Oracle database are system and sysaux, and I've given you a diagram down below that shows you the standard table spaces that come with Oracle. System is where your data dictionary objects exist. All of the objects in system are owned by the sys superuser. Sysaux is used as overflow space or auxiliary space for system objects. Those are absolutely crucial to database operation. And when we're using a container database, we have one system and one sysaux that serves the entire CDB/PDB implementation. More on that in just a second. Some other built-in table spaces that are important that you can see in the diagram down below are the undo table space, and remember, each table space has one or more data files in it. Undo is extremely important for things like read consistency and the ability to undo changes. User A deletes a bunch of rows from a table, but they haven't yet committed that transaction. The previous image of those rows before they were deleted is temporarily stored in your undo table space in your undo data files, so that additional users who are querying that data will see the before image. So that's giving us what's called read consistency. Undo is also used by Oracle Flashback to be able to restore data that's been deleted or modified. It's really crucial to database operation. And then other than that, you can deploy additional table spaces to store user data and application data. And what's cool, and this last bullet point brings this out, is that as a DBA, you can put management policy on your table spaces. So you could create a table space with data files just for a specific user group or schema or application, and then add things like quotas. You can set a table space to read only. You can do a lot of cool administrative stuff to protect the data on that table space. For instance, you might have a bunch of schema objects that are historical, and you don't want anybody modifying them, but you do want to allow people to select against those objects. You can put those objects in a separate table space, which is a logical item, but those items would be moved, and there's various ways to move data around that we'll talk about later, to data files in that new table space. Set the table space to read only, and that's a very quick way to be double sure that nobody is going to modify that data. You can also give yourself parallel processing by putting those data files on separate disks. You might have a schema or group of objects that are very heavily utilized, and you might want to put those data files in a table space on a separate disk spindle. You see, this is less important with solid state disks, but if you're still using, say, serial attached SCSI or SAS disks, you definitely do want to consider parallelization wherever possible. In this slide, I just want to show you a picture of what I meant earlier in terms of a segment, a table index, let's say, can span multiple data files, but cannot span multiple table spaces.